Now, let's discuss on the next topic, that is definite integrals. Now, so far we were dealing with indefinite integrals. Indefinite integrals, I had told you that there is a c there. After integration, we used to put a constant of integration c. Now, here in definite integral, as the name suggests, the integral is of definite value. For example, the integral x square plus 1 into dx. Now, for definite integral, you have the values on the integral. We call this as limiting values. This is the lower limit, this is the upper limit. Now, how to find the value of this definite integral? So, integral which is given in the form integral 1 to 2 x square plus 1, or in general, integral a to b f of x dx is called as a definite integral. Now, how to find the value of this integral? As usual, I will find the integral of this function. That is, x square integral is x cubed by 3 plus x within the limits 1 to 2. Okay, so here I have discussed on the integral 1 to 2 of x square plus 1 into dx. Now, here I have integrated the function as it is x cubed by 3 plus x. When I integrate x square, I will get it as x cubed by 3. Integral of 1 is x. Now, upper limit minus lower limit. So, when you find upper limit, 2 cubed by 3 plus 2. This is upper limit minus lower limit, 1 by 3 plus 1. That is 8 by 3 plus 2 minus 1 plus 3 by 3. Or here I can even write it as 8 plus 6. Okay, 3 into 2, 6. 6 plus 8 gives you 14. 14 by 3 minus 4 by 3. What is that? 10 by 3. So, this is the definite integral value. So, the value of this integral, of this definite integral, integral 1 to 2 x square plus 1 into dx is given by 10 by 3. Okay, so now let's move on to the next exercise, exercise number 7.4. Okay. Now, let's discuss on some more problems. So here, the first problem is to find the integral of integral 0 to pi by 2 cos square x dx. Now, the integral value, the limiting value will remain as it is till the last step of integration. First part is to integrate cos square x dx. So here when you integrate cos square x, how will I write cos square x? Direct integration of cos square x is not possible. I need to write this as 1 plus cos 2x by 2, correct? Into dx. So this is 1 by 2 times integral 0 to pi by 2 of 1 plus cos 2x into dx. Now I integrate this. That gives me 1 by 2 into x plus integral of cos 2x is sin 2x by 2 within the limit 0 to pi by 2. Now I apply what? Upper limit minus lower limit. That is, in the place of x I will substitute what? Pi by 2. So pi by 2 plus sine of 2 times pi by 2 by 2, that is upper limit, minus lower limit 0 plus sine 0 is again 0. Okay. So this gives me 1 by 2 times pi by 2 plus 2 and 2 cancels. What is sine pi? Isn't it 0? So, I get the value of the integral as pi by 4. Am I clear? I get the value of integral as pi by 4. Now, let's move on to the next question. That is, integral 0 to pi of sine squared x minus cos square x into dx. Now, in order to do this, I take a negative common outside. So, integral 0 to pi of cos squared x minus sine square x into dx. Now, I may write this as, how will I write this identity? I can write this as cos 2x, cos 2x. So, I get this as integral of minus of integral 0 to pi of cos 2x. Integral is what? Sin 2x by 2. Isn't it? Sin 2x by 2. So, this integral sign goes where I get the value 0 to pi. Now, I substitute. Substitute for what? I substitute for minus of sin into 2 pi by 2 minus sine 0. Okay. So now what is, this gives me minus of sine of 2 pi by 2 minus sine 0. Now what is sine of 2 pi? It is again 0. So I get the ultimate answer as 0. Am I clear? Now we have the problem integral 0 to 2 of 2x plus 3 by x square plus 4 into dx. Now here I may write this integral, or I split this integral 0 to 2 into 6x by x square plus 4 into dx plus 3 times integral 0 to 2 of 1 by x square plus 4 into dx. Now this could be written as, if you take this part denominator as u, won't you get the numerator in its derivative? So if I take u is equal to x square plus 4, I get du is equal to 2x dx, or du by 2 is equal to what? X dx. Now, one thing that you have to keep in mind here is that I have changed something here. What? I have changed x square plus 4 into u. Now, once when I change this in definite integral, this limit value also must be changed. That is, when u is equal to x square plus 4, that is when x is equal to 0, when x is equal to 0 implies u is equal to what? U is equal to 4, isn't it? Because I am going to change this u. If I am going to change this x square plus 4 into u, then the limiting value will change accordingly with respect to u. So here when x is equal to 0, u is equal to 4. Then when x is equal to 2, implies u is equal to what? 2 square 4 plus 4, that is 8. So this integral now I can write it as integral. In the place of 0 I have 4, in the place of 2 I have 8. 6 is outside. Now x dx is du by 2, and this is 1 by u into du by 2. Am I clear? Plus 3 times integral 0 to 2 of 1 by x square plus 2 square into dx. Now this is equal to, when 2 comes outside, this becomes 3. 3 into what is the integral of 1 by u? That is log u, correct? Within the limit 4 to 8 plus 3 times, what is the integral of this? 1 by a tan inverse of x by a, x by 2, within the limit, because 2 I am putting as a constant, within the limit 0 to 2. Okay, so this becomes 3 log 8 minus log 4. Okay, minus 3 by 2 into tan inverse of 1. Tan inverse of 2 by 2, that is 1 minus tan inverse of 0. Now this is equal to 3 into log of 8 by 4 minus 3 by 2 into, what is tan inverse of 1? We know that it is pi by 4, and tan inverse of 0 is 0. So what will we get here? 3 log 2 plus 3 by 2 into pi by 4. So I can write it as 3 pi by 8. So this is the final answer. I just made a change here. It was plus. Earlier I wrote this minus. So it is plus again. Okay. So that's it. 3 log 2 plus 3 pi by 8. Okay. So that means for a definite integral, the value of the integral will be a finite value. Okay. That is why there is no c there. The integration constant is being replaced with a constant value for the integral. Now let's move on to the next question. Here I am splitting this integral into two. 0 to 1 x e raised to x into dx plus integral 0 to 1 sine of pi by 4 x into dx. Now this part, if you look at that, is direct integration. What is the integral of sine pi by 4? It is negative of cos pi by 4 x divided by pi by 4. That is the integral. We know that. Now here I need to apply what? I need to apply integration by parts. So I need to decide on which is the first integral and which is the second integral. So which is the first integral here? As you know, x is the first integral, being the algebraic function. Now when I integrate this, first function is x. First function into Integral of the second. Integral of e raised to x is e raised to x within the limit 0 to 1 minus integral of 0 to 1 for, so first function into integral of the second minus integral of derivative of the first. Derivative of x is what? 1, and that of integral of e raised to x is e raised to x into dx plus, what about the integral of this part? That is cos of, negative cos of pi by 4 x by pi by 4 within the integral 0 to 1. Okay, now the integration is not over. X e raised to x within the limit 0 to 1 minus integral of e raised to x is what? E raised to x itself, 0 to 1 minus this pi by 4. This becomes 4 by pi into cos of pi by 4 into x within the limit 0 to 1. Now I apply the upper limit and lower limit. When I apply the upper limit, e raised to 1. 1 into e raised to 1, that is e raised to 1 minus 0 into e raised to 0. E raised to 0 is of course 1, but 0 into e raised to 0 gives you 0 minus this part, e raised to 1 minus of minus plus e raised to 0. E raised to 0 is now going to be 1 minus 4 by pi into cos pi by 4 minus cos 0. Okay, so this gives me this and this cancels. E raised to 0 is 1 minus 4 by pi into, what is cos pi by 4? I know that it is 1 by root 2 minus cos 0 is what? 1. So finally I'll get this as 1 minus 4 by pi root 2 minus of minus plus 4 by 5. Or this way is also fine, or I can just expand and write it like this also. Okay? Am I clear? Go through it. Now we are going to discuss on some properties of definite integrals. Now you may refer to page number 341 in your textbook. Listed below are some properties of definite integrals. Now the proof of this is given in the textbook. Just go through it. It is not a very important one, but it is also not like you can just skip it off. So just go through it and try to understand it. Okay. Year before last, one of these properties was there in the proof section for your board exams. So proof is, till that particular time we used to say that proof is not that important, but I cannot say that it is not important now, because you just need to go through the proof. It is very simple proof, 1 or 2 steps proof. You need to go through it, and if you have any doubts regarding any of the proofs or any of the substitutions, you can ask us during the meet. Okay, so now I am listing the properties. So the first property is integral a to b f of x dx is equal to integral a to b f of t dt. What does that mean? Even if the integral value, the variable changes in the integral value, the limit value will remain the same. Okay, the variable changes in the function, but the limit value can remain the same. Now coming to the second property, integral a to b f of x dx is same as minus of integral b to a f of x dx. What does that mean? When the limits interchange, the sign of the integral reverses. I repeat, when the limits interchange, the sign of the integral reverses. Okay. Now coming to the third property, that is P2. Integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx, where c is a value that is lying between a and b. I repeat, c is a value lying between a and b. Now, that means I am splitting the integral into 2. Okay. Next one, integral a to b f of x dx is equal to integral a to b f of a plus b minus x into dx. I repeat, a plus b minus x into dx. So the value of the integral will remain the same. In the fourth property, the fifth property, that is P4, it is integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. It is just the a particular case of the integral just given above. Okay, so integral 0 to a. In the above integral, it is a to b. In the second integral, it is written as 0 to a. So, the integral 0 to a f of a minus x dx. Then, coming to the next integral, property, integral 0 to 2a f of x dx. I repeat, integral 0 to 2a f of x dx. I can write it as integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. F of 2a minus x dx. Now, coming to the next property, integral 0 to 2a f of x dx is equal to 2 times integral 0 to a f of x dx. If f of 2a minus x is equal to f of x, that means integral, that means in the function f of x, if I substitute for 2a minus x in the function and still I get the function as f of x itself. Okay, in the function f of x, I substitute for f of 2a minus 1 in the place of x. If the function is changed with 2a minus x, and again if I get the integrand as the same of f of x, then I can say that the function is what can be written as in the form of 2 times integral 0 to a into f of x dx. That means here I can call this function as an even function. So, if the function is even, it can be, that integral can be written as 2 times integral 0 to a f of x dx. Now, this is just, or else it is 0. Or else it is 0. That means if 2a minus x is substituted into the function and you get the value of the function of f of x, then the function is said to be an even function. And the value of the integral will be 2 times integral 0 to a f of x dx. Or else you get it as minus of f of x. That is, f of 2a minus x will give you minus of f of x. In that case, the value of the integral will be equal to 0. Now, this is coming to the in general. In general, I can say the next property that comes up, integral minus infinity to infinity, sorry, minus a to a f of x dx. It is minus a to a f of x dx will be 2 times integral 0 to a f of x dx if f is an even function, that is f of minus x is equal to f of x. And this integral minus a to a f of x dx is equal to 0 if the function is an odd function. That means if you substitute for f of minus x in the given function, you will get it as minus of f of x. So, here there is one more thing that I want you to understand, that is what is an even function and an odd function. In the function, if I substitute for f of minus x and get the value as f of x, then I say that the function is an even function. If I substitute for x is equal to minus of x and I get it as minus f of x, then the function is said to be an odd function. So, I repeat the integral. Integral minus a to a f of x dx is equal to 2 times integral 0 to a f of x dx if f is an even function, and integral minus a to a f of x dx is equal to 0 if f is an odd function. I hope it is clear. Now you can go through the properties in the page number 341 and understand it with the